Hello everyone, this is Pravesh Malviya. Today we are going to discuss about the EMF equation of the transformer. Now, what happens when we supply alternating current in the primary winding of the transformer? A flux of alternating nature set up in the core, and that flux linked with both the windings, the primary as well as the secondary winding. When it links with both the windings, it results in an induced EMF in both the windings. So an EMF E1 is induced in the primary winding and EMF E2 is induced in the secondary winding. So the EMF induced in primary winding is the self-induced EMF and E2 is the mutually induced EMF. So for both the induced EMF we will develop some mathematical equations. So what happens when a sinusoidal voltage is applied to the primary winding of a transformer? Alternating flux set up in the iron core of the transformer. This sine flux links with both the windings. So look at the circuit here. Here we can see two electric and one magnetic circuit. The first is the primary circuit. Primary circuit is having N1 number of turns. When we supply V1 voltage across its terminal, current I1 flows through the coil, which sets up a flux phi in the iron core. This setup flux links with the secondary circuit having N2 number of turns. It also links with the primary circuit. So when this flux links with both the circuits, it results in induced EMF in both the windings. So looking at the waveform of the flux, now we can see here that the waveform of the flux is of alternating nature. So why it is so? Because we are supplying an alternating supply to the primary winding. So the flux which is set up is also of alternating nature. So here we can see that this is a waveform of flux and the waveform is completing its one cycle, a complete cycle. So we can see that it is having a positive half and a negative half. The positive peak is plus phi m of the flux in Webers and negative peak is the minus phi m. So but we have divided it in an half cycle, that is 1 by 2f. This 1 by f is the time period of this cycle and 1 by 2 is the half time period. As shown in our figure, we can see that the flux changes, the magnitude of flux changes from plus phi m to minus phi m. We are talking about only this duration. Here we can see that the flux is changing from minus phi m to plus phi m to minus phi m. Now, by Faraday's law, let E1 be the EMF induced in the primary winding. This E1 is the induced EMF in primary winding when the phi flux links with the N1 number of turn, and EMF E1 is induced in the primary winding. So according to Faraday's law, induced EMF is equal to minus d psi by dt. This psi is equal to N1 phi. This psi is the flux linkage in that particular winding, and in which winding it is linking in the primary winding. So the flux linkage for the primary winding will be N1 phi, where N1 is the number of turn in primary and phi is the flux which is linking. So we can write here E1 is equal to minus N1 d phi by dt. Putting the value of N1 phi, putting the value of flux linkage in equation 1, we get this equation number 2 here. Since the flux is due to AC supply, so it is also of alternating nature. So we know that the standard equation of an alternating quantity is like this: phi is equal to phi m sine omega t, where phi m is the maximum value of the flux. So flux is also an alternating quantity here. Now putting the value of phi is equal to phi m sine omega t in equation number 2, we get E1 is equal to minus n1 dt d by dt phi m sine omega t. Furthermore, by differentiating we get this value equation, and we get equation number 3, which is E1 is equal to n1 omega phi m sine omega t minus pi by 2. So this equation 3 clearly states that the flux that the induced EMF is lagging behind the current by 90 degree. Now the maximum value of the flux is when E1 max is equal to n1 omega phi m. So this is equation number 4. But we know that omega is equal to 2 pi f. So putting the value of omega in equation number 4, we get E1 is equal to 2 pi f n1 phi m, where f is the supply frequency, n1 is the number of turns, the primary winding, and phi m is the maximum value of flux. So this is the maximum value, the peak value of the induced EMF. Now if we go to find out the RMS value, the root mean square value of the induced EMF, it's like E1 is equal to maximum value of the induced EMF by root 2. So we get equation number 7 here by putting the value of maximum value of induced EMF in equation number 6. We get the equation number 7, which is E1 is equal to root 2 pi f n1 phi m. Now putting the value of pi in equation number 7, we get the equation number 8, that is 4.44 f n1 phi m. So this is actually the induced EMF in the primary winding. It is 4.44 phi n1 phi m, where f is the supply frequency which is being fed to the primary winding, n1 is the number of turn in primary winding, and phi m is the maximum value of flux in the core. So E1 is the EMF equation for the primary winding. Now the same flux links with the secondary winding too. So for the secondary winding, induced EMF will be 4.44 f n2 phi m. Here everything is same in these two equations, but only number of turns are different. As we earlier discussed that the induced EMF in both the windings depends upon the number of turns of the same winding. So induced EMF can be different because number of turns can be different. So for the secondary winding, E2 is 4.44 f and 2 phi m. Here we can see that frequency in both the equation, frequency is same because frequency does not change. Whatever frequency we fed to the primary circuit, we get the same frequency from the output side, and flux is also the same. The common flux links with both the windings, primary as well as secondary. But the induced EMF in both the windings differs just because of the number of turns. So this is all about the EMF equation of the transformer. Thank you very much.